So here I've just started out this morning with this distilled water. This is my second batch I'm making of this particular variety because it came out such a nice product yesterday. So I'm using this distilled water, just a great value product. It's not necessarily great distilled water, it's good distilled water. They sell it in Walmart in big boxes, 4 liters. I've tried quite a few times. You can see I've tried quite a few times to perfect this, and I think I've come to at least 50 parts per million, if not more. I got my silver coin here, which I've cleaned up. It doesn't look cleaned up, but it's cleaned up. I just use an emery cloth on it, or some toilet tissue paper, and just scrub off all the stuff builds up. You'll get some discoloration, that's okay. And then I've got just really simple. It's just a graphite pencil lead for my cathode. Now the cathode, you can still see there's some silver on here. I wiped it, but there's little bits of silver on there, which is normal. This'll there, you can sort of see some of the shine on it. It's different than the graphite color. And the other part of the component, I use these little French jam jars, Bon Mama or something like that. Bon Maison Mama. No, it's Bon Mama. So good mother jam from France. It's delicious, and you get these nice little drinking cups out of it. And this one I've sort of pilfered for use with just this purpose in mind. And at the bottom there's a little, I wiped it out and I've washed it, but you can see there's some silver burning in there. It's really hard to get them off, and I've scrubbed that and it won't come off. So this one's not for drinking out of. Some people drink colloidal silver. I wouldn't. I'm not going to get into why, but just reference Blue Man, you'll see why. And then what you need is a Pringle lid. If you can get one of these, some sort of container like these Bon Mamas jars, they're great, and you only need one. I use 2 because I pour it off into another, but you need another container to pour it through coffee filter later. And in a Pringle jar, you just cut a slit the same size as your coin, a little bit smaller maybe, and then you just cut a hole in it. I just used the knife to cut a hole, but first what I do with them is I put a piece of clear packing tape over the top, not over the bottom because it'll just get wet and contaminate your water, on the top, and then I just trim it, and then I cut it. And what that does is it stops it slows down so it doesn't wreck I mean, if you try and cut into this plastic with just a knife, right off the bat, like, you just need a slit, hey, nothing fancy, but it cracks. And so I put this piece of packing tape over top of it, and it really gives it a nice reinforcement for when you're poking the hole in it. And I just use a steak knife and cut it, and then you just put that, and it snaps right on top. And I'm not going to heat this water or anything. The last batch I didn't heat. And then I just take my coin, and I find that slit here, it's right here, and I just push it down. I fill the cup almost full, and then I push it down just so it's sticking out a little, and then I put my lead, my graphite lead, in the other end, just so it's sticking out. So you want them to go down into it a good ways. Now you can use 2 silver coins. I have another silver coin. I feel like, I'm wrecking my coins doing this, but really, what would I use a silver coin for? And I'm going to hook I know this red and black one is my cathode. I'm just going to turn it. And I know this one. And my power supply is already set up. And I've just got this power supply. I made this one out of an old computer, really old 1990s computer, maybe 1980s computer, power supply box. And it's neat because it screws off and the top comes off. You could make one of these. I think the 30 volt power supply, 0 to 30 volt with current, so it's a voltage and current limiter circuit, and I think just a PC fan. I put an old hard drive fan on there, or some sort of, actually it's not, it's just these were we used for cooling computers a long time ago, these big heavy ones. Now they're much smaller. Now when I turn it on, and I'll just get my DC volts.
DC 6.0 millivolt.
Yeah, that's, I don't know what it's reading. My leads are over here. Well, I'm just going to hold this with my left hand. I'll just put the red one and the black one. And I got 9.6 volts. And that's what I did yesterday. I'm not going to change it because 9.61 volts, and it really worked good. So I'm going to leave it. I'm going to leave it right there. And just straighten this one out. Hang on, I'm just going to unclip this and push it down a bit and try and reclip this thing. I had it really good yesterday. Just was nice and relaxed. These cables are gonna give me a problem today. They got wrapped or something. Oh yeah, there they are. Okay, so there. I just push it down like that. Now that you see, there's no way this lead can interrupt and put zinc into my mixture. You don't want the leads touching. You don't want these alligator clips touching because they're copper coated, but they're coated with nickel, and nickel's toxic. I don't know if it's toxic to plants. I'm not drinking this stuff. I wouldn't drink it. I don't want to turn blue, and I prefer vitamins. But anyways, in the water, you can see my graphite one. Now you don't want them to touch the side. You don't want them to touch the side. And there's no danger of the coin touching this side. But I sink it down a ways. Yeah. There. Like that. And you just leave them, and they're about 1.5 inches apart, almost 2 inch, not quite. They're about 1.5 inches apart. And I leave it there, and I set my timer on the phone right away, and I'm going to leave it there for about 6 hours. 6 hours and 20 minutes, I think. And you'll see it's starting. See, there's hardly any, you can hardly see any line in there, hey? So we'll see what happens there. But you can see little particles starting. But in the distilled water, there's almost nothing in there for it to, the light to bounce off of. So you get, and this is just a low voltage green laser, but it's powerful enough for this purpose for sure. It's just get them on eBay for about 30 bucks. You don't need it. I don't have a TDS meter, so I won't be able to show you exactly how much I'm getting, but I'm pretty sure it's gotta be. I'm running at low voltage, and the theory of that is that if you run at high voltage, you break down, you run more energy through the water, you're running more energy through the silver, and the ionic extraction happens very fast, and it tends to break things down very quickly. It's like a traffic jam of nanoparticles. They don't become nanoparticles, they try to force out as macroparticles, and so you get a big slime of silver on top of your water. A little bit of that is okay. We're trying to resist that, and the color we're shooting for is a straw colored yellow, like a straw gold kind of color. And right now you can see this plain as day. This is clear, clear, clear. And I'm going to come back at the end of this process, towards the end of the process, or the middle, and I'll show you how much more that beam, how much more that, I don't like shining this beam. It's really, if you catch that in the eye at all, that's just not a good deal. These green lasers are really dangerous. Don't ever point them at anyone, especially yourself. And You can see it just kind of goes everywhere. I mean, you can see the dot. That's where it's going in. And you can kind of see a little line. Don't pay attention to that refraction where it's breaking there. That's just the facet on the glass. But I'm shining it at one of the facets. And so when I'm looking through this facet, you can just see it's a straight line, but it's very faint. Well, that might change later, so just keep that in mind. So we're about a few minutes into this experiment, a minute or two, and we're going to come back and just make sure your anode and your cathode and your anode, your anode and your cathode don't touch the walls of the glass. You don't want it depositing. You don't want it shorting. You don't want it, because it will. It'll make a ring around your. That's what happens when I use the high voltage. I actually end up having I had a big layer of silver on my glass, and what was happening is there's extra energy polarizing the glass, and the glass, as we know, it can conduct electricity. So we don't want anything to touch it. What happens is it will film impurities on it, and then more and more and more and more, and then you get a layer of basically turn it into a mirror, and we don't want that. So you want the leads, the silver coin, the cathode, the anode, and the cathode, the graphite, or another silver coin. Don't use anything else. Use either graphite or a silver coin, and you put them so that they're not touching. And these Pringle lids on these Bon Mama jars, we have them in Canada, where it's wonderful, and we can mess around with growing weed now and try and make all kinds of things happen with it. We're only allowed 4 plants, and we have to keep them to 32 centimeters, or just under 3 feet. You can't go over that. So lots of tie downs and stuff like that. But I mean, you know, it's such an economy now that nobody sells weed anymore. Everybody can grow their own, and everybody wants to grow their own. I don't like, I don't want to eat. I wouldn't want to eat food that was mass produced in some unknown country with weird chemicals in the ground. I don't really like that, and we do it here too. I mean, every farmer, I'm sure, has to put some pesticides in the ground, but I don't enjoy that. I would rather eat out of biologically safe ground, so I make my own soil. And this is another word on this stuff here. If you spray colloidal silver on your plants, for the love of God, don't consume those plants. It is not a good idea. Do not smoke them, because heavy metals of any kind in the body are just not good for you. And you'll hear people say, "Oh, I take colloidal silver." Well, if you're taking good colloidal silver for the body, it's going to be less than 10 parts per million, maybe 2 parts per million. If you get more than that, you're going to start to get all kind of liver toxicity and all kinds of weird things. And I'm not an expert in that, but you just have to look on the internet and you will see far too many examples for them all to be not true. Now, for spraying crops and for feminizing plants, you know what? This is the safest of all the alternatives. I wear a mask when I spray it, but what I don't do is consume it. When I'm doing seed plants, they get put in early, they get taken out early. I don't crop them. I'm only looking for seeds. And why I'm looking for seeds is not for marketing. I'm looking for seeds so I can modify the plants that I grow. And again, we're limited here to only 4. So it's a long, slow process. But you know what? It makes it a little more careful. And the strains that I'm working on and the genetics I'm trying to enhance on them are going to be done in real soil with clean water, no added chemicals. Maybe some bootstrap molasses mixed in a tablespoon of that into my gallon of water towards the 3-month period at the end, or 3-week period at the end, sorry. But that's about it. I don't actually put anything. I use compost. I compost, and I keep all my soil for my plants in jugs or in containers so that it doesn't get any bugs in it. And if you're growing indoors, it's the way to go. You're going to save yourself there. You can see this beam is already starting to get some silver in it. Now you can't see at this voltage. There's not clouds of silver dropping off the coin. When I ran it at 30 volts, which somebody said you should do, man, that was coming off like a cloud, and I could see it. So if I can see it, it's not a nanoparticle. Nanoparticles are microscopic and very, very tiny. And in this, you can just see a little bit. The ones that are shining, that are dancing there on the beam, those are not nanoparticles. Nanoparticles will be virtually invisible. They will give the water kind of a straw-like gold, light gold tinge. And at the end of it all, I run the water through a brown coffee filter, and not a strainer. Don't put anything metal in this water. You will deionize the silver, and it will drop out. And as soon as I'm done here, after I've strained it into another glass, I then pour it into a brown glass bottle, and store it in a dark, cool room. Do not freeze this. Do not refrigerate it. It just needs to be kept in a cool, dark place. Don't put it somewhere where the sunlight's going to hit it, because that will take the net. That will affect and cause all the silver to drop out, and you'll end up with just a bunch of white stuff on the bottom of your container and nothing. Now, I mean, why it's called colloidal is because the nanoparticles of silver are caught up in some form of medium. In this case, water. So we've got water and nanoparticles, and they're caught up. So that means they can't drop out. They have a charge and they repel each other. They have like charges. They're all positively charged, and they are ionic. So they are they're in the container of water, and they're at such a state that they're in a colloid, which means they are suspended, and that's all it means. So the process of making this is ionic. We're making electricity come in and go out, come in and go out, and what's happening is there's an ionic exchange back and forth, negative, positive, negative, positive, negative, positive, and at the energy frequency, or the energy level that you put it at will determine how fast that rate is. And you want it to be a slow, steady lineup. You don't want it to be a traffic jam. A traffic jam forces the particles behind it to become bigger to get out. The more energy it takes to push them out, the quicker and more yellow. Now you could probably get some effect out of it, but it won't be nearly as good, I don't think, a product as if, or steady a product as if you could slowly push them in, and they'll bump each other out of place, and they'll start to deposit on the cathode, and they'll start to blacken as it dumps back on the anode. It will actually get a coating of oxidization from the water, and that's a part on the what happens on the. Now, I'm not a chemist. I have some rudimentary power engineering and stuff like that, but and some water treatment. But what I believe happens on the anode, on the cathode, on the anode, on the red part, the positive, is the reaction of the silver ions, or the silver molecules, are reacting with the constituents of the water, carbon and oxygen, and it's causing an oxidization. And that, if you go too fast, will happen faster. The coin will turn black, and in order for the silver ions to get out, they have to knock off the carbon, so you get carbon in your water as well. And carbon is very good, like in a diamond structure or graphite structure. It's very good at moving around. Why these graphene conductors are really good is all of the molecules in carbon are very close together, and they want to bump, and they go to higher levels and lower levels, and they flow very back and forth very easily, and they're stable, and they don't want to shift out into the water. What happens is, if you take them out of the water and you deposit them onto the anode, they then now become free carbon atoms, In other words, they're blocking the way of the silver ionic exchange, and they will end up depositing in the water. So you get this really darkening effect of the water, and it looks more like, I don't want to say it, but it starts to look like piss. And you do not want that. You want that straw gold, majestic kind of light gold tinge to the water, or else clear. And then you'll know you're between 10 parts and 50 parts per million or more. But without a TDS meter to test the solids in the water, there's a couple different ways you could do it. For our purposes, for feminizing plants, we don't need that. We're only using this on the females to make them turn into males. So we're actually masculating the plants and trying to make them produce pockets of pollen instead of flowers. So the interesting process of that is that the silver, ionic silver, at a certain size can pass through the membranes of the plant and react with the copper uptake and stop it from producing ethylene. And this works with plants, not with people. So you're not gonna turn yourself into a male if you're a girl and you spray this stuff on yourself. This is for plants because they rely on the trace copper elements in the soil. And I'm talking, you don't have to add copper to your soil. It's already in there in different levels. The components of that metallic copper in your soil that get uptake by the plant during its flowering process. What decides that it's female is that it can produce ethylene and such. Now, if we interrupt the ethylene cycle with ionic nanoparticles that can pass through the plant, and nothing bigger than nano-sized, I mean microscopic sized, is going to be uptaked through the plant. You have to have that really small particle. Large clumps of silver are not going to cut it. They'll just sit on the plant and stifle the leaves, and you'll get a burning effect possibly. What you want is you want to spray them so that the plant gets confused. It goes, I don't have any copper, I must be a male, and starts producing pollen sacs instead of using the available ethylene and starting to produce flowers. So very quickly, that in a nutshell is my understanding of this whole process, and I believe it to be correct. It was done in a dissertation back in 1978, and there's a hardcover book out on the market, it's on the internet, and you can read it for free. There's that particular excerpt of pages. I think there's about 25 of them. If you like chemistry, you can read through that and find all that stuff out. But people have been doing this a lot longer than I thought. And when I came across this, I thought that's worth a try, because rather than relying on hermaphrodite plants that are stressed by environmental conditions, I don't want to promote that. So if it happens once or twice, that's okay. If it happens more than 3 times in a row, you're starting to make plants that want to turn hermaphroditic, that is, to have both male and female sex organs. That's not good if you're trying to get weed that has substantial THC content to it. So this is a trick system. This is a way of tricking the system where we attack the ethylene in the plant and allow the plant to pretend it's a guy for a couple of weeks. And once the ethylene cycle has been interrupted, you're off to the races, and you'll have lots of pollen. And then you can pollinate till your heart's content. Please do not freeze your pollen. Your pollen will not freeze. Don't freeze it, that wrecks it. Put it somewhere cool and dark and dry, and in a jar. Again, glass is the best. Don't store this stuff in plastic. Plastic has static charge, can pick up static from the room, and will destabilize your silver ions. You don't want to put it in anything but dark glass. Don't put any metal near this. If you put metal in it, it will be ruined. Just store it in a glass jar in a dark place, And if it can't be guaranteed to be dark for 6 months or however long you're going to use it, I don't make enough of it to store it long term. Just put it in a dark jar if you're going to store it for longer. There's some beautiful capped jars you can buy of beer, jugs of beer. I use one of those, and that's all you need. Anyways, I'm going to shine this light in here. You will see, you can start to see the beam, but it's still pretty faint. I've been talking here for about 20 minutes, so I'm going to go and we'll come back and check on this later. It's just a simple process. If you don't have this, you can use batteries. Lots of guys who show you how to put the batteries on there. Just a 9-volt battery. You can put them in series and have a little bit more current, but you don't want more current. Current is the enemy of production here. We want reasonable current and 9 volts. And we'll check back on this later.